Okay, guys, so today we're going to review the exercise that we saw in class. It's going to be obviously a very quick review of what we saw in class. Some of the first types of ways and simple ways to do the forecast, okay? I'm also going to show you how you can check the exponential smoothing with one of the tools here in Excel, so it's much easier for you. So we have this particular exercise and we saw it. It's Don Federico, he's a barber, and there are some days that he has a lot of clients and some days that they're not doing really anything. And so what he wants to do is he wants us to predict or forecast how many clients he's going to have in week 6. So he knows if he needs to hire more or he needs to let someone have the day off. So here we are, we have our data. He gave us this data for our first 5 weeks and it's Monday through Saturday, okay? For this first part of the exercise, we're only going to be trying to predict or forecast week 6. So the first one is going to be, what we're going to do is try to find the averages. Why? Because we're trying to find the forecast for the whole week, not specifically for Monday, Tuesday, Wednesday, Thursday. This is important for when you try to do it with other exercises. Not in all exercise are you going to have to do this first step of averaging. We're averaging here because we're trying to predict the number of the whole week, okay? The average number that he's going to have each day, but considering the whole week. So we're going to put average. Okay, and we're going to pull our formula. And then we're going to try to find the average of the whole the average per day of the whole 5 weeks. So again, we'll do an average of the averages. And this number is the same number as if I was doing the average of the whole days. Okay, so I have the same number. Just so you can see it, we have the same number. When we go in and we start with our methods, we saw the naive method, and the naive method was just to take in consideration that the forecast of the period before is exactly the same as the forecast for this period. So the naive for week 6 is going to be the actual data that we have for week 5, okay? The simple average here is going to be, like it says, it's a simple average. We're going to be taking the average of all the periods that I have. So from week 1 to week 5, and I take the average. So considering this, I'm actually considering that for my naive method, I have 3167 clients, 32, and this is very important, we don't round them up until we find our final average, okay, until we make our final forecast. In between that, we're always considering the decimals. The next one was the moving average, and remember that the problem gives you this magic number of 3 periods. It can be 2 periods, it can be 4, 7, it depends on each problem. This one is not something that is not always going to be 3 periods. It can be 4 or 5, okay? You will see that in the mini case, you have a lot of years of information, but there's in particular 1 year or 2 years closer to the very end where there is a big change of amount, okay, of sales. You have a big change, it goes up. Would you take the average of a lot of periods or taking those that are very similar to what I'm living? Considering that I am actually working with considering that I'm actually going to be working with a problem where the tendency is going up, I would maybe choose the fewer periods, not the whole period, okay? So moving period, it's very simple. It says average, you're going to take the average. It says N3, so you're going to take it for the last 3 periods. Week 3, week 4, week 5, okay? Then the wage moving average considers, this one is very important because it's one of the first metrics that it starts to say, hey, we need to take and give it more weight to the last periods. That will probably give us a more certain type of answer, a more certain type of forecast. So what I need to do And this one, again, the problem will usually give you the numbers. Here, we're only taking two periods. We're taking period or week 4 and week 5, considering we're going to give it the weight of 80% to week 5 and 20% to week 2. But if we're taking 3 periods, our percentages might be different. It might be 70 for week 5, it might be 20 for week 4, and it might be 10 for week 3. Okay. And all I have to do is take the average and multiply it plus the average of the next period times the 20%. And that is going to give me a 32, telling me that my forecast is going to be a 32. The next exercise, and this one is considering the exponential smoothing. The exponential smoothing uses alpha, and alpha has to do with our data. Alpha, and we're going to see beta tomorrow. But alpha is really what it's going to consider is the movement of our data, how it moves. And this particular function or this particular method, what it's going to do, it's going to try to soothe all these points, all these points of prosperity and not so much prosperity, these going ups and down points. It's going to try to soothe the line a little bit. And what it's going to do, what it means by soothing is it's trying to reduce my error. Okay, it's going to try to reduce my error the best way possible. So that is what I want to do. So that's what I'm going to do. So I'm going to try to reduce in the best possible way with this, the error that I have. This is the first time we're seeing one of the errors, and we're going to see a lot more tomorrow. But the first error is going to be very simple. It's from the difference that I'm going to have between what I had today, the actual amount that came in today, for example, minus what I had forecasted. Okay, so that's going to be like my error if you're in class, in a math class, and the difference between what the teacher solved and what maybe you solved. And right now, what I'm going to do, and this is for this particular problem, okay? We're going to do it right now with also with the data analysis tool from Excel. We're going to do that. But since we have to have a starting point. That's basically what we have to do. We have to have a starting point. So we're making up a fictitious week. And this fictitious week, we're going to call it week 0. And if I bring my data, and this is my data, this is my actual data, this is what Don Federico gave me. So it's right there, okay? I can make this data up. What I actually want in this data is to have a 0 error. I want to make sure it's a 0 error, and it has to make an educated guess. So I can't put here 100. If I know that my week 1 daily demand or daily clients is going to be 24.2, okay? So why did I put 2? Because I have 24.2 clients that are coming each day. So it can be 25, it can be 24, it doesn't matter. Okay? I'm just saying I can have 0.2% of a person, okay, come in with me. So I'm putting 25, and here's the trick, is that the forecast of my fictitious week is also going to be 25. It has to be the same. Why? Because I want this particular error, which the error is always the actual minus the forecast, and I want it to be 0. Okay? So what we're going to do is now we're going to try to forecast. This week is a forecast, and here is the formula. There are some other formulas, there are some other textbooks that give you a different formula, and that is perfectly okay. It gives you the exact same answer. And this particular formula says, give me the forecast that you had in the previous week, plus what we're going to try to multiply is my alpha times the error that I had previously. And it's giving it a lot of value, or it's giving a lot of value to my last periods, but also it is going to try to soothe it. That means it's going to try to reduce that error that I have. This number, by the way, the 0.5, the problem will usually give it to you, or you can choose it randomly. Whether all you need to know is that it has to be between 0 and 1. It doesn't matter if it's 0.2, it doesn't matter if it's 0.7. We're actually going to use solver to find the minimum alpha in a minute. But right now, you can choose a random number, okay? So what we're going to do is we're going to get the forecast of my previous period, which is 25, plus my alpha. Okay, plus my alpha, and I'm putting it in these absolute reference so that I can pull my formula. Times, I open parentheses, and to get my error, it's going to be my actual minus my forecast of my previous period, close the parentheses, and I have 24. If I come back and do the same, that means that my forecast right now is considering 31.26. Okay, 21.26 clients, not a bad number. It's very close actually to all my other numbers. Let's find the error. The error, like I said, is going to be my actual minus my forecast. And here's my error, okay? Now look at this, and this is very important. I can actually look at this and say, okay, I have a negative error. Is a negative error wrong? No. It doesn't matter if it's plus or if it's a negative number or positive number. If it's a negative number, all it means is that my forecast, what I forecasted was above what I actually had. Okay, so I'm having a more optimistic view. When it's a positive number, what it's saying is that my actual data was above what I actually forecasted. So you can see I had 29.8 clients came in, and I forecasted that it was going to be 26.8. Okay, so what I did there, and here is basically saying that I was a little bit more pessimistic with my forecast. What I'm going to try to do is I'm going to try to reduce this particular number. This is my last error. And what I want is to try to reduce this the best I can in order to get a better forecast. Because if my error is 0, then I have a better forecast. How do I know this? I'm going to graph this. I'm going to graph the weeks, my actual and my forecast. I'll go to insert a dispersion graph, and here it is, okay? So my blue line right here, this is my actual data. So if you can tell the spaces between my actual data and my forecast, that is my error. And what I want to do, and if you can tell, it's very, very close to week 5. But what I want to do is I want to make it so that my forecast is as close or as certain as possible. And that will happen when my error is the smallest. So let's go and do that. We're going to do that with Solver. And we're going to go to data and Solver. Okay. And what we're going to do is, let me erase all my data here so that we're able to do it right now. Okay. So my objective right now is going to be try to reduce this. And I can reduce it as much as possible, but it can give me a negative number. Or I could just say, hey, make it to 0 or as close as possible to 0. So that means 0, no error. Changing what? Well, I want you to change my alpha. I can't change my data. I can't change my actual information that already happened, but I want you to change my alpha. Find the right alpha so that this number, my error, is 0. What is it considering? Well, my restrictions are considering that my alpha, if you remember, has to be between 0 and 1, is greater than, is less than or equal to 1. That means it can't exceed 1. And my alpha is greater or equal to 0. That means it has to be above 0. And here's very important. We got to make sure that it says nonlinear. It cannot be simplex. It's going to be nonlinear. I solve it. And now it's telling me that the best answer that I can possibly have, considering this information, and I didn't run it complete, I stopped it without running it, is in order to have the least number, or in order for my error to be the least, which in this case it was able to find a solution with 0 error, my new forecast is 31.67. So this is pretty good. I have a really good data here, good information, and now I'm going to, if you can see, by the way, that it's actually the same as my naive method, very close to my moving average. But what I'm going to try to see now, or to show you, is how we worked this This is my new average, okay? 31.67 is how you can also do this outside in not having to do it by formula. Okay, so I have all my data here. This is my data, my clients, week one, and the average. There's actually a function here in data, and it says data analysis. And there's one option here that says exponential smoothing. In exponential smoothing, I'm going to go ahead and put that, and it says, what are my entry data? My entry data is right here, okay? And what is my coefficient? It's going to be 0.5. And I'm going to go ahead and tell it that I want them to put my answer right here. And I'm forgetting one thing, and I'm sorry, it's your data plus one more. Okay, your data plus one more. And I can tell it to give me my error and my graph. And I'll go okay. And if you can tell, I'm going to go back here so that you can see 0.5. My answer was 31.26, which is the answer that this is the forecast that the formula in Excel is giving me, which is 31.229, okay? With an error of 3.49. This is the error that it's actually given me. So this is another way you can do it, except if you see this particular error is not giving me my optimum that I found right here with Solver. Okay, and you'd have to play a little bit with that in order to figure out this magic number. But if I put this, let me go ahead and put this one over here. Oh, sorry. Exponential smoothing. It says it's going to correct it. This so you don't see it. Okay, and let me just do it again because, so it's, don't know if that was actually the number, okay? And here is my actual answer that now it's given me, which is 30.43, okay? Which is a little bit lower than this because of my decimals. This is not considering all of the decimals, okay? But as you can tell, it's giving me another variable.